Assalamualaikum and hello everyone. We are from Group 4 for BMM3521 Engineering Fluid Mechanics Lab. So, as per the abstract for the experiment is this report is for our fourth experiment in engineering fluid mechanics lab. The title for this experiment is series of parallel pumps. In this experiment, we are to determine the pump performance with three different configurations that are single pump, parallel pump, and series pump. We have to identify the delivery pressure, suction pressure, outflow pressure, flow rate, net height, power, and the efficiency to determine the pump performance by those three different configurations.
Hello everyone, I am Kavinath, son of Appalsami. My metric number is MA19055, and today I am going to present the introduction, which consists of background, problem statement, objectives, and scopes. So now let's look at the background. Pumps are energy absorbing devices since energy is supplied to them, and they transfer most of that energy to the fluid via rotating shaft. The increase in fluid energy is usually felt as an increase in the pressure of the fluid, but not necessarily an increase in the speed of the fluid. So, in simple words, the energy input will be higher than the energy output for the flow, which is depicted in the picture here. So there are two basic types of pump. First is the positive displacement pumps, which force a fluid into or out of a chamber by changing the volume of the chamber. The pressure develops and the work done is a result of static forces rather than dynamic effects. The human heart can be taken as an example of this type of pump. Next is the dynamic pumps, which add momentum to the fluid by means of fast-moving blades or vanes or certain special designs. The fluid increases momentum while moving through open passages, then converts its high velocity to a pressure increase by exiting into a diffuser section. The best example for this type of pump is a jet pump. Dynamic pumps generally provide a higher flow rate than positive displacement pumps and a much steadier discharge, but dynamic pumps are ineffective in handling high viscosity fluids. Pumps rise up the head of fluid by energy conversion. The output power is dependent on the pump efficiency, which can be calculated by dividing the output power with the input power. So now let's look at the series pump. So this is the performance curve of a series pump. So series pump are basically centrifugal pumps arranged in series, which are used to overcome larger system head loss. For two identical pumps in series, the head will be twice the head of a single pump at the same flow rate. Given a piping system which has a known design flow rate and head requirements, the following pump selection criteria apply. So for the selection criteria, assume that the pumps are identical, and each pump must provide the following, which are the required design flow rate must be equal to the flow rate of the pump, and the required head must be equal to twice of the head of the pump. So now let's look at parallel pumps, and this is the performance curve of the parallel pumps. So parallel pumps are centrifugal pumps in parallel which are used to overcome larger volume flows. Two identical pumps in parallel and the head kept constant and the flow rate doubles compared to a single pump. Given a piping system which has a known design flow rate and head requirements, the following pump selection criteria apply. For this, we assume that the pumps are identical. So the design flow rate, the required design flow rate must be equal to twice of the flow rate of the pump, and the head requirement must be equal to the head of the pump. So now let's look at the problem statement. So pumps are widely used in all sectors these days. It is also can be said that pump usage is inevitable in daily lives of ours. In this case, selecting the correct pump is always been a challenge as a wrong selection could heavily cost. Not only that, the arrangement of the pumps is also a matter which has to be taken care of, even if the perfect pump is selected. Determining the best arrangement of the pumps will be a huge task to deal with. This is because the arrangement of the pumps varies according to the situation. By doing this, the efficiency of the pump will be increased and the performance will be better. In this experiment, we are to determine the relationship between the flow rate of the fluid and the head loss using different arrangement of the pumps, like a single pump, series pump, and parallel pump. Through this, we believe we can make a decision on the pump performance and the output pressure from each type of arrangements. So the objectives of these experiments are: first, to design complete measurement technique for fluid flow and determine pump performance with single pump, series pump, and also parallel pump configuration. Next is to investigate the relationship between pressure head, flow rate, power consumed, and the efficiency of for a pump. And finally, to compare the performance curves of different pumps. And scopes of this experiment: first of all, calculating the efficiency of different arrangement of the pumps. Next is utilizing the appropriate arrangement of the pumps in diverse situations. And finally, scrutinize the variance between the experiment performance curve to its theoretical curves.
Assalamualaikum warahmatullahi wabarakatuh. My name is Cik Siti Nuraisha binti Cik Sapi. My ID number is MA19093. Today I want to present about the chapter 2, which is theory. Pump is basically a mechanical device imposed on the pipeline which convert the mechanical engineering supplied from the external force, later resulting in liquid flow from lower potential to high potential. In this centrifugal pump experiment, it has been set up to a manual setting, hence it will be easier to switch between series and parallel setup. In series parallel centrifugal pump setting, the volumetric flow depends on the pressure that generates within the pipeline. When the pump pressure low, the volumetric flow high, and when the volumetric flow high, the pump pressure low. Okay, for the pump connected in series, the pump pressure are added together, but the volumetric flow remain the same. So this is the formula for series. So we just use this formula to get the data. On the other hand, the pump connected in parallel, the volumetric flow of the pump are added together. The achievable pump pressure remain the same. This is the formula for parallel. So we need to use this formula to get the data. Thank you.
So I will continue for the chapter 3, which is method and procedure. Okay, for the apparatus, we have a water tank, manometer, centrifugal pump, pressure gauge, manual valve, and hydraulic power input. Okay, next, we go to the procedure. Firstly, we set the selection valve to a single pump configuration. Then we switch on for both pumps using the main switch. Then the volume, flow rate, and corresponding pressure record. And then step 2 until step 3 was repeated using different volume flow rates. Okay, then the experiment was repeated by changing to series and parallel pump configuration. Okay, lastly, the total of net heat and water horsepower was calculated for each experiment.
Assalamualaikum and a very good day. My name is Muhammad Akram bin Jamal Akbar and my ID number is MA19099. So today I would like to present to you chapter 4, which we will cover result and discussion. So here we have assumption and properties. We have 4 assumptions. The first one is at all conditions, the water will be assumed in room temperature, which is 25 degrees Celsius. The second one, the fluid flow is steady and incompressible. The third one, the flow at the pump inlet is turbulent and fully developed. And the last one, there are no leaks in the gaps between loops and casing. For the properties, we will assume that the density of water to be exactly 1000 kg per meter cube, and gravity of acceleration is assumed to be 9.81 meter per second square. So here we have 3 formula that we use for the calculation. So for the first one, we have the head. The head is equal to P over rho multiplied with G. The P we will represent to the pressure, rho is density, and G is gravity acceleration. The second formula is net head, which is equal to H1 minus H2. And the last formula is the water horsepower. The power output equal to rho multiplied with G multiplied with Q and multiplied with H, where the rho is density, G is gravity acceleration, Q is flow rate, and H is net head. Here we have the experiment data for the single pump configuration, and also I state the sample calculation for the single pump. As you can see here, also we have the sample calculation and data for the series pump. And the last one here, we have the parallel pump configuration data and the sample calculation for the parallel pump. Next, we go to the graph. So the graph shows the performance curve for single pump configuration. The graph correlation shows that pump head decrease as the flow rate increase. This relationship states that pump head is inversely proportional to flow rate for single pump. Next, we have series pump configuration. The graph correlation shows that pump head increase as the flow rate increase. This relationship states that pump head is proportional to flow rate for series pump. And the last one is parallel pump configuration. The pump head increase as the flow rate increase. So this relationship states that pump head is proportional to flow rate for parallel pump. So the last one, we go to the discussion. For the first one, compare the experiment performance curve to its theoretical curve and describe the discrepancy factor. So my answer is it's hard to get identical data since there are a lot of discrepancy factor. This factor was affecting the curve for experiment data. The discrepancy factor that might affect the data from getting the theoretical curve is fluctuation of flow rate and losses in the pipes. The second discussion is to from the result obtained, state the use of series pump and parallel pump. So for the series pump, we use it to deal with larger system head loss than a single pump can manage. And while the parallel pump is used to deal with higher volume flow than a single pump can manage. The last question is explain why the system with series pump configuration would generate higher pressure than the parallel pump configuration. So in series configuration, every pump controls the same flow rate. The total head produced by the group of pumps is additive. Since the total head is the sum of all head, the pressure increases as well. While the parallel configuration, the flow rate is additive. At the same capacity, each pump will produce the same heat and the pressure maintains for each in parallel configurations. I think that's all from me. I will pass the presentation to the next presenter. That's all. Thank you.